This video is about the derivative of composite function. First, I want you to be familiar with this notation. When we write f of g of x, it's the same as f of g of x. And it means you insert g of x into f of x. For example, if f of x equals 1 over 1 plus x, and g of x equals, let's say, x squared minus 1, then f of g of x is equal to 1 over 1 plus g of x, because we replaced x of f of x with g of x, is equal to 1 plus, since g of x is x squared minus 1, the final answer would be 1 over x squared. Likewise, we can determine what is g of f of x, which means you replace x of g of x with f of x. So it means it becomes f of x squared minus 1. And since you are given the equation of f of x, we can come up with this. But this is what we learned before. Now we need to learn how to differentiate the composite function. So it's simple. F of u prime equals u prime f prime u. And as you know, u is an expression or a function of x. We can also write this as they are same but different notations. So f of g of x prime is g prime x f prime g of x. So for example, if you want to differentiate f of sine x, all you need to do is to differentiate sine first, the inside function, which is cos x, times f prime of sine x. So this sine x plays the role of u here. So I followed that instruction. Or if you want to take the derivative of, for example, let's say h of ln x. So all you need to do is that taking the derivative of ln x, which is 1 over x times h prime ln x. Okay, let's have another example. If g of 0 equals 1 and g prime 0 equals 2 and f prime at 1 equals 3. So what is the value of f o g prime at 0? So f o g prime at 0 means we take the derivative of f of g of x and then we replace x with 0. So f of g of x prime, according to what we learned, is equal to g prime x times f prime g of x. So once you replace x with 0, you'll get g prime 0 f prime g of 0. So g prime 0 is given, which is 2, f prime, and then g of 0 also is given 1. Now we know that f prime 1 equals 3, so the answer would be 2 times 3, which is 6. This is how we take the derivative of composite function. I'm going to give you another example. Given x f of x squared plus 1 minus 2g of x equals 3x plus 2 if f of 5 f prime 5 equals 3, what is the value of g prime at 2? Okay, you are given an equation, and since the question is about g prime at 2, we need to take the derivative. And oh, by the way, I'm going to add one more piece of information here because we need f of 5 too. Let's say f of 5 equals -1. So you are given this information. Now we are looking for g prime at 2, which means we need to take the derivative of this equation and then we replace x with 2. Okay, if you look at this yellow one, it's the product rule. So we need to differentiate. The derivative of x is 1 times f of x squared plus 1 plus, now we need to take the derivative of f of x squared plus 1, and we just learned that we need to take the derivative of inside function first. 2x f prime x squared plus 1 times x minus 2g prime x equals 3. Now all I need to do is replacing x with 2. So it becomes f of 5 plus, so we have 2 times 2 f prime 5, we have another 2 here, minus 2g prime 2 equals 3. f of 5 is given -1, and 2 times 2 times 2 is 8 times f prime at 5, which is 3, minus 2g prime 2 equals 3. So 8 times 3 is 24, minus 1 is 23, minus 2 g prime 2 equals 3. I'm going to take 23 to the right side, so it's going to get 2 equals -20. Now I'm going to divide both sides by -2, so therefore g prime at 2 is 10.